Yeah, there were really two drivers behind the project. On the one hand, the towers were approaching 50 years old and were in need of repair work to the actual brickwork structure and the concrete frame itself. And at the same time, Peabody had internal targets on reducing their overall SAP emissions from all of their properties as a whole. And the vast majority of their properties are very hard to treat Victorian mansion blocks. So this was seen as a win-win situation. By overcladding, they can accommodate the repairs that needed to be done and at the same time improve the SAP values quite significantly on the project. Tower blocks like this tend to be less problematical because they had less features on the outside of the building, so you can easily recreate them in the EPS or wrap the EPS over the top, as in the case of the roof, to accommodate the thermal bridging. The weak points would be around the windows themselves, but particularly around the balconies in this situation, because we had inset balconies. So we really had to ensure that the insulation carried over the parapet walls, down the inside in fact, and across the balcony terraces. And the knock-on effects of that were the need to introduce window linings internally to minimise disruption to the existing decorations. And wherever there's a balcony, there's now a step up to get onto that balcony to obviously accommodate the greater depth of insulation. The overcladding itself uses a Stowe insulated render system, and it comprises a 200mm expanded polystyrene slab layer that is both mechanically and adhesively fixed to the existing fabric of the building. And then there is an acrylic render which is applied to the surface of that with a mesh to allow it to bond to the EPS system. And the advantages of that are that it's a jointless system, so you don't see joints all over this building because it can accommodate the thermal movement. But it's quite lightweight, so it's not adding tremendously to the weight of the building and the foundations. And the 200mm of EPS gives approximately a U value of around 0.18, I think. So that's a significant enhancement from 2.1, which is the U value that would have been previously. The windows are supplied by Velfac. They are a double glazed low E argon fill window system. The opening casement is in the same alignment as the internal frame. They're a composite window, aluminium on the outside, timber on the inside. And what that means is you can still accommodate the overlap of insulation to reduce thermal bridging around the window reveals, but without compromising on the size of the opening glazed area itself because of that overlap. And the fabric improvements to the solid areas and the windows themselves, together with an upgrade of the boiler systems, contributed an improvement in the SAP rating from around 35, 36 to low 80s. So it's a huge improvement just by fabric measures alone. There was such an impact on their heating bills during that first heating season, or the first quarter, that although they don't admit to it, the utility company sent out an investigator to establish whether there was in fact any tampering going on with the metering or the supply system, because they had also noticed such a huge reduction. So it really does have an effect.
Yeah, so we're in Newham, near Canning Town, and this is Ferrier Point. We're on the 22nd floor and about to have a look at ECD's next kind of tower block refurbishment underway.
Well, let's have a look in a typical flat. So we're facing east here, and we've got an equally impressive view the other way of the city of London. Yeah. But this, I mean, as you can see that as a main road there, the A13 in from Essex is one of the reasons why London Borough of Newham wanted to make this a flagship redevelopment. Yeah. I have a building, a 60s building. It's 40 years old. It's, you know, it's getting tired. It needs repairs. But with the overcladding works, it can have another 40 years of life. And there was an opportunity to make this a kind of flagship project because of its prominence in this part of London, and particularly within the Canning Town, you know, regeneration area. Yeah. So the approach to that really is to overclad the existing building literally with the existing fabric still in place. So residents carried on their occupation as per normal with their windows on the inside, whilst new windows were placed on the outside. So we're moving the thermal envelope outside. And then it's not affected by weather, and the opportunity to take the old windows out is at the behest of the contractor rather than weather dependent. It's a rain screen solution incorporating 200 millimetres of rock wool insulation on the outer face of the original concrete panels. The concrete panels themselves did have a certain amount of insulation value with a kind of wood wool slab type arrangement, but that's been enhanced with the rock wool. Then there's a ventilation void, and then an aluminium rain screen finish that goes on the outside to give that kind of luminescent appearance of the building. So we're in the living room now, and originally this would have led onto an external balcony, which some residents would have liked for purposes of growing plants or what have you, but there's no doubt that this height is quite disruptive in the wind. To simplify the overcladding, but also to extend the living area of the flats, we've enclosed these in what are in effect winter gardens. So you still have a high performance envelope on the inside face, but you have a second envelope on the outside, which is where the insulation has been continued. And that allows you to utilise this space however that might be, whether it's as like a conservatory style space, or if you're drying clothes you can open up these windows to allow that moisture to disperse out of the building. So it just adds to the flexibility and at the same time simplifying and improving the thermal performance. In conjunction with that, we've got these triple glazed windows installed, partly to help combat the noise of the traffic from the dual carriageway down below, but obviously there's thermal benefit to be gained from a triple glazed thermally broken aluminium window in this case.
Quite, I suppose, a good example of how a lot of the kind of passive house methods in terms of overcladding and insulation and new windows give you an opportunity to do something else, say on the renewable side of things, or as well as a kind of creating a flagship for the area. So.
Absolutely.
Yeah, so now I'd like to talk about a project you've got on the boards called Petticoat Tower, that it's really taking your experience and putting it all together and looking at achieving what's known as the InnerFit standard, the passive house equivalent for a retrofit project.
The refurbishment program ultimately is intended to incorporate rain screen overcladding, replacement of windows, improved air tightness and retrofitting of mechanical ventilation with heat recovery. Working with PHPP, we have established that we can approach the InnerFit standard relatively straightforwardly, and the form of the building as a tower block helps in that most flats only have 2 or maximum 3 exposed sides. We use the PHPP software to input the usual floor areas, the U values of the windows, the psi values of the cold bridging around those windows. We've based it on a Passive House certified heat recovery ventilation system. And we clearly at this stage we're making assumptions that we can achieve the air tightness, but it's an in situ concrete tower block, and quite often they have very good air tightness from the outset. So
yes,
I think we've
measured
measured similar flats before, and they're already at an air tightness of 3. So with good attention to detail around the windows and around service risers, we're confident that we can approach the higher levels that InnerFit requires.
Great, right. Well, thank you very much.